pressure, precipitation, relative humidity, and atmospheric boundary condition. There are two types of prediction model. First one is a statistical model and machine learning model. A statistical model uses linear regression or time series analysis, and machine learning uses decision tree or neural network. I will choose IMA model over others due to its robustness, interpretability, flexibility, and availability. IMA stands for Auto-Aggressive Integrated Moving Average Model. It is a time series forecasting technique which is used to predict future values based on the past observation. In IMA, historical pollution data series is examined for autocorrelation and seasonality. There are three components of IMA model. First one is auto-aggressive, second was integrated, and third one is moving average. IMA model are denoted in the form of PDQ, where P denotes number of autoaggressive terms, D is the order of differencing, and Q is the number of moving average terms. These are some literature review which I have mentioned here, and the outcomes and the finding of this literature review is that many authors uses single pollutant or one or two pollutant. Some of them uses large small data set, and some of them have not uses meteorological factors. And in some paper I have found that they have not validated their model with the unused data. Objective of the study. Our objective is to establish a auto-aggressive integrated moving average model in our programming for air pollutant, namely S5 suspended particulates matter, sulfur dioxide, and NOx from the data of 2016 to 2022. And after that, we have to evaluate the effectiveness of the IMA model in predicting concentration of key pollutants, ISPM, SO2, and NOx with the unused data of 2023. These are the methodology in which first we have to collect the data, and after that we have gone for data pre-processing. In this process, I have removed the incomplete data or missing values and convert into the suitable form which is accepted by the IMA model. After that, we go for assessment of the collected data, and then we have to select the best fitted model, and then we have applied diagnostic checking, and then we will go for forecasting. After forecasting, we have validated our forecasted value with the actual value, which is unused data, and after that we have gone for model refinement. Our study area is HCCT, and I have collected data from Jharkhand State Pollution Control Board and meteorological data from NASA's website MERAS-2. I have collected 8 years of air pollutant data, ISPM, SO2, and NOx for the period of 2016 to 2023. This is the result part. After collecting the data, we have to find the p-value which should be less than 0.05, which is the significant limit. And in all three models, we have get the value less than 0.05. And on the basis of that, we have selected the model which we got for ISPM. Its value is in the form of ISPM model is in the order of 112, and for SO2 it is in the order of 313, and NOx it is in the order of 212. It model is selected on the basis of list value of AIC and BIC, and the list value for the selected model is mentioned here. This is the trend analysis graph of ISPM concentration. Here we can see that during 2016 to 2017, our concentration of ISPM is lying between 180 to 2225 microgram per meter cube. And after during the mid of 2018 to 2020, we can see that our value is lying between 110 microgram per meter cube. And in that part, the plain line signifies that this is the lockdown phase during data is missing. And here we can see that at the end, there are two spikes have been seen. One at the end of 2018 month, and second one at the end of 2021 during the winter season. This season This is the month of November to December. This is winter season or festive season, November. This is the auto-correlation function and partial auto-correlation function plots for the ISPM raw data and ISPM residuals. In the ISPM raw data, we can see that at all legs there is seen a spikes. In the case of the ISPM raw data, which is much above than the dashed line, which is the confidence interval. And after applying differencing, we can see that in the residuals all comes below the dashed line. Similar case for the PSCF plot. This is the SO2 concentration graph from the year 2016 to 2023. Here we can see that there are 3 spikes have been seen, which are nearly at the end of the year 2018, 2020 and 2022. And this is the ACF and PSCF plot for the SO2 residuals and SO2 raw data. This is the trend analysis for the this is the trend analysis for the NOx, and here also we can see that there are 3 spikes have been seen, one at the end of the 2018, 2020 and 2022. And this is the ACF and PSCF plot for the NOx raw data and NOx residuals. Similarly, here we can also see that during in the raw data there is the spikes, and after applying differencing there is no spikes have been seen. It means our model is working. And similar case is done for the PSCF plot. As I have mentioned, p-value should be less than 0.05. It means that we can reject null hypothesis in favor of the alternate hypothesis. This is the prediction graph. I have predicted value for the next 30 days, which is lying between the blue dashed line showing the fluctuations data. The next 30 days value is fluctuating between these intervals. Similarly for the NOx graph SO2, and similarly for the NOx. This is the graphical representation of the actual data and the predicted value. Here observed value is showing in the blue line, and red line shows the predicted value. We can see that these are almost similar but not exactly same due to the less data. If it can be improved if we take a large data set instead of 7 years. Similar cases for the NOx, SO2 and NOx. And finally we can conclude that the output shows that for the ISPM predicted value was around 105 microgram per meter cube, while the observed range is lying between 102 to 106 microgram per meter cube. Similarly for SO2 prediction, around 17.2 microgram per meter cube, which is a close agreement with the observed value of 16.8 to 17.5 microgram per meter cube. If we talk about the NOx, then predicted value was near 36.2 microgram per meter cube, which is much closer than observed value, which is 35.6 to 36.6 microgram per meter cube. We can improve by combining multiple models. We can improve the accuracy by combining multiple models such as AIMA with neural networks or other machine learning techniques, which could address the limitation of each model. Thank you. Thank you.
Thank you, sir, for the wonderful presentation. Now, may I ask the audience for any questions?
You can go to the observation site where you have shown predicted and your observation and predicted values are very, very different. And however, you are showing that your predicted values are closer to the observed value, but there is no match. So I think this model is properly not working. Your PDQ value should be different. You are considering 1-1-1 model. That is not correct, I think. And perhaps your ACF correlation here, that is also not proper. So that seems, this is my suggestion.
Yes, ma'am. My order model is for ISPM, SO2 and NOx. They are different models, having different order of PD and Q.
Have you tried with different legs?
Yes, ma'am.
How many legs you tried?
Ma'am, I think there are many models, but I have tried 4 to 5, ma'am. Different having different lag value.
For example,
ma'am.
T plus 1. How long you have got?
Ma'am, T plus 3, ma'am.
for all these three sets of
Yes,
that
ma'am.
you are
Out,
purchasing,
out of these, ma'am, these are the best, ma'am. These are the best model out of all.
what kind of data you are using in raw data or having utilized?
Raw data, ma'am.
You should try with utilized data.
Okay, ma'am.
Then log transformation you can add up
Okay,
as a
ma'am.
transformation method.
Any more questions?
Okay, ma'am. Okay, ma'am. We will.
Any more questions? Okay, thank you, sir.
Thank you. Thank you.
With this, we move to our next presentation. Influence of vertical vibration of geogrid reinforced soil, presented by Mudassir Alam, sir. Sir, please.
वो पॉइंटर है इससे आगे पीछे वाला इससे आगे वाला इससे आगे वाला ये पीछे वाला और ये लेज़र लाइट है वहाँ से करना ठीक है
Good afternoon, Chair, respected delegates and respected scholars present here. Am I audible to you? Okay. So my name is Mudassir Alam and I am recently passed out MTech student and I am here to present my paper which is titled as Influence of Vertical Vibration on Geogrid Reinforced Soil. Here is the outline of my presentation. I will first introduce my topic and then I will go through literature review, objectives, methodology and results and discussion. Okay. Bearing capacity of foundation design mainly influenced by subsurface condition and types of loading. Load can be static, dynamic or lateral. So dynamic bearing capacity of the soil depends on nature of dynamic load. Limited research has been done in the field of dynamic load in comparison with static load. So there are many types of dynamic load and which are seismic loading, transient loading, periodic or pseudostatic loading. So here are some of the literature I have used during my research work and the key finding of the literature review is that in the field of geogrid reinforcement soil, static loading has been considered so much times, but dynamic loading condition has not been explored much. So I have decided to explore this area. So here is my objective for this research paper to study influence of vertical vibration on settlement of geogrid reinforced soil, to study the effect of geogrid stiffness and to study the effect of friction angle on soil with vertical vibration. So there is a machine which rotates on different velocity. So I have used different models for my analysis. The machine rotates on 800 RPM to 1000 RPM. Here is my model for the analysis. These are the soil properties I have considered during my research work. This is the loading mechanism, a special type of machine which only generates vertical vibration. This machine is for the purpose of vertical vibration only. This is a special kind of machine. There is a two mass which rotates in opposite direction and generate only vertical vibration. This is called Lesion type mechanical vibrator, which is generally used in laboratory. This is the load description I have used while analysis my model. So for different machine speed, for 8000 RPM of speed, maximum force amplitude was 5.6 kilonewton and the frequency was 13.33, and with increasing speed frequency also increased, as well as maximum force amplitude also increased. So here are my key findings. So this is one of my key findings, that influence of frequency on vertical displacement. So the curve which is on the top of this graph is for vertical vibration before using geogrid, and the lower curve is for vertical settlement after using the geogrid. So here we can see that after use of geogrid reinforcement, the settlement reduced significantly. This is another graph which shows the influence of friction angle on vertical displacement due to machine vibration at 1000 RPM. So here we can also see that with the increasing friction angle, vertical displacement decreases. So we can say that angle of friction influence vertical displacement. Okay, and the third key finding is influence of axial stiffness of geogrid on vertical displacement due to machine vibration. So if we increase the stiffness of geogrid, it will significantly reduce the settlement caused by dynamic loading. So this is my conclusion, that increased frequency leads to greater vertical displacement above the geogrid. Geogrid reinforcement significantly reduces displacement below the geogrid, and at a small induced vibration load, bearing capacity of soil does not get affected. And another finding is effect of geogrid reinforcement. Stiffer geogrid are more effective at controlling vertical displacement. Bearing capacity increases with inclusion of geogrid reinforcement. And effect of friction angle. Soils with higher friction angles show better resistance to displacement under dynamic loads. Thank you. Any question? Thank you for your attention. I would like to acknowledge Dr. Abhijit Anand sir and Dr. Sanjay Kumar Shukla sir in person